Okay, cool. So how we're going to run this today is we have two parts that we're going to do. So myself and Ramzy are going to demonstrate two different things today. So Ramzy is going to start off by demonstrating site-to-site VPNs on ASA, and then it will pass over to me once it's done, so I can demonstrate the configuring of site-to-site VPNs using firepower via the FMC. So there's two parts. Hopefully we'll be able to get through all of it in the time that we've allocated for this. If we are getting towards near the end, I'll try to be as quick as possible with my part. We won't really touch on all the great detail in terms of the protocols, etc. But we can definitely see how we configure site-to-site VPNs on both ASA and firepower. So if you are not speaking, can you just make sure that you're on mute so that we can avoid any background noise? And again, this session is recorded, so you will be able to watch this back at a later date. So with that, I will hand over to Ramzy, and I'll give it over to him to start his presentation. Thank you, Ramzy.
Yeah, thank you. First of all, can you see my screen, guys? Everything's okay? My voice, everything's good?
Yep, sounds good to me.
Okay, good.
Yeah,
Okay.
Cool.
Okay, good. So first of all, hi everyone. The new guys, my name is Ramzy Abudaya. I work in networking, mainly network security for 4 to 5 years now. I work a lot in Cisco products. Mainly 80% of my work is using Cisco products. I work on Palo Alto's too, mainly everything related to security. I work on F5 products. I work on also Arbor, if you ever heard of it. It's for DDoS attacks. And I got a little bit of insights on like cybersecurity, forensics, penetration testing, and so on. Regarding today, we're gonna be talking about site-to-site VPN. Actually, this should be like a fun session with a lot of knowledge. I'll be sharing a lot of the things that I know. I'm of course ready to listen to people who like also know things, want to share. It's an open space. Everyone can share, but if you have questions, if you can leave it to the end, it will be better. If not, you can go ask right away. It's okay. First of all, I really sorting a presentation up and doing the design and everything, because I like talking more than preparing. So yeah, so I just figured this presentation up. It's mainly straightforward, but I'll be focusing on talking much more, because I need you guys to be listening to me more than reading from the slide. So that's my way of doing things. So let's get started. Okay. Okay. So today's menu, I'm gonna start by stating what is a VPN connection. Of course, we've got people here that are beginners, people who never heard of VPN. Maybe we have intermediate people. Maybe we have experts. So it's okay. It's for everyone. I'm gonna start with saying what's a VPN, telling you what's a VPN. Actually, we're gonna jump to the VPN types. Third part will be the dirty technical stuff. We're gonna talk about what's a VPN technically and how is a VPN built. I'm gonna try to say the whole story from A to Z. Afterwards, I'm gonna jump to the demo where I'm gonna be doing a simple sketch of ASA configuration using CLI.
ये तो स्वाभाविक है और गणेश मुझसे छोटा भी है और उसमें क्या
Can you just make sure you're mute if you're not speaking, please? Just see that. There we go. I think that's done. Sorry about that, Ramzy.
Yeah, it's okay. So I was saying I'm gonna do a demo using ASAs. I'm gonna virtualize a VPN environment to show you guys how everything is working out. I'm gonna do the configuration on the CLI. You're gonna see this for those who love CLI. I love CLI too. So I'm gonna do it on CLI, and I'm gonna show you on ASDM how it's done. It's very, very simpler than CLI. I'm not gonna do it on ASDM. I'm gonna show you how we're gonna do it on ASDM. After that, we're gonna jump to I will be sharing my experience regarding troubleshooting. I will tell you what are the things that you should be looking at in case someone call you up and say that I have a VPN problem, everything is down, and you need to check it. I'm gonna tell you like my experience and how to think in troubleshooting a VPN problem. And final part will be Q&A. After that, we're gonna jump to Kelvin. He's gonna like show you guys how everything's done on FTD using FMC, which is the device management center for the firewalls. You're gonna see it there too as a lab. Okay. So what's a VPN? This is a very big question. It's also like very simple. For me, a VPN connection is any connection that is secure, mainly over internet or over a WAN connection, whatever, MPLS, whatever type of connection, as long as I am using this infrastructure in a secure way, that's a VPN. Okay, so I could be working from home, I could be like on the streets, connecting to the head office, using resources there, entering data, taking data, all of these stuff. As long as they are secure, they are considered to be as a VPN connection. Of course, we have many types. We have many devices that do VPN, but mainly a VPN is any connection, okay, that is encrypted, secure over an infrastructure, mainly it's internet or WAN, okay, or any sort of infrastructure that's transmitting data over a public sector, over a public infrastructure. So for an example of VPN, you might guys be surprised that you can know that SSH is a VPN connection. By the way, SSH is just a secure connection. If I'm accessing like SSH through SSHing from my house to let's say a router anywhere using the real IP, that's considered a VPN connection because actually it is encrypted, and I'm using certificates to I'm using the certificate to follow this encryption mechanism. So it's a VPN connection. So that's pretty much covers what is VPN. I'm sure you guys know this stuff, but I thought that if someone didn't know, that's it. Okay, because like 5 years ago when I started in networking, I used to ask my friends, what's a VPN? I didn't really grasp the meaning of VPN. For me and for most guys, I know you're gonna get familiar with the thing that I'm saying now. VPN for me is like accessing a server to be able to see websites that are forbidden in my company or in the country. So that's not a VPN. That's actually a proxy. It is a VPN, sure, but it's mainly a proxy thing that I'm getting out of the internet from another place. Okay, so the real VPN is here. Okay. VPN types. So this is a very good picture. I think it like represents all VPN types that you're gonna guys be seeing in your careers. I'm gonna talk about Cisco, but the concept is major to any vendor actually. In Cisco VPN, there are two types that you need to think of. Major types: site-to-site VPN, which gonna talk about today in details, and there is the remote access VPN. In site-to-site VPN, most of the time it is IPsec. What's IPsec? We're gonna talk about it in the next slides, but the most used like VPN types are site-to-site VPN, get VPN, DM VPN, and flex VPN. I'm gonna talk a little bit about each. Site-to-site VPN is basically what we're gonna do now. I have a head office, I have a branch. I wanna communicate with my head office in a secure way. I go for a VPN, and that's probably it. Get VPN on the other side. Get VPN is it's a big thing. It's a big deal actually. It is not mainly used because in Get VPN, you guys need to have the ISP. The ISP should know your internal subnets. So we use mainly Get VPN in a place where we have many sites, head office, whatever. I use Get VPN with the provider. Okay, it has some sort of advantages, but mainly the ISP should know your internal subnets, because as he's routing information or your packets, he is going to be routing based on your internal subnets. Okay, so we use mainly Get VPN in these types of things. DM VPN, I think that's the most used type of VPN. It's actually using the internet, using anything MPLS. It is secure. It is amazing. Usually done on on routers because until now, DMVPN is not supported on ASA. I'm going to talk about it later, why it's not supported, the DMVPN scenario. And the Flex VPN. Flex VPN, actually, it is like DMVPN, but we're using IKV2. What's IKV2? Again, I'm gonna like mention it in the upcoming slides. It's just like IKV2 is just like more secure, more options. It's like the next generation of using the IKE phenomenon. Now today we're gonna be talking about IKV1. Okay. So remote access VPN, actually, I'm sure most of you are familiar with it. We are using it's like two types. It's for client where we ask the user or anyone to like install any connect on their laptops, and then they can connect to the router or ASA at our head office using the real IP. It can use IPsec or TLS. TLS, for those who do not know, it's like the next generation of SSL. It's like it uses the same mechanism as you actually accessing a website, but it is using it for any connect for the VPN connection, or you can use IPsec. You can use both in any connect. And there's something that's the client list. Client list is you can benefit from client list VPN and like some scenarios where it is tough for everyone to like access to like install any connect on their laptops. But definitely any connect is better. But client list is used for some scenarios where like you do not need to install the package. Plus, your aim from the VPN is doable using client list. Client list is actually you just opening a web browser, nothing else. You're gonna use the real IP of the or the DNS resolvable fully qualified domain name of the VPN on your web browser. You're gonna get like the page opening. You're gonna go for username and password. Afterwards, using a Java or web-based application, you're gonna like access the resources. It is somehow limited, somehow, but mainly now people do not use it. It is still used, as I said, in some cases where you do not need to install, you do not want to install any connector. There's something I remembered now. I'm sure also most of you heard of it. It's called like VPN client. VPN client is like the old days. It's like the pre AnyConnect. Okay, so it's like AnyConnect. It's actually a client also. You use it to connect to the VPN. Okay, so understanding how VPN works. IKV1. Okay, so I'm gonna like mention what are the most important things for me in a VPN that will make you guys understand the VPN deep down, how it goes. This will help you a lot in like thinking and how to troubleshoot VPN and how to install VPN or configure VPN. I'm gonna talk a little bit about encryption, which is mainly the most important thing in VPN. I want you guys to know about the packet flow. Actually, when I receive a packet on the firewall, I want you guys to know step by step how does this firewall analyze this packet, the stages that this packet flow in order to be received by the end user or something. We're going to talk about phase one. It's called Isakmp. I'm going to talk about it later. Phase two, which is the IPsec itself. And finally, I'm going to like tell you the whole story on how everything is working. But to tell you the whole story, I need to cover the first 4 points. Okay, so encryption in brief. I don't know, guys, if you are familiar. I think you should be familiar. If you like did CCNA security, this should be familiar to you. Encryption. Okay, so cryptography is mainly encryption and hashing. Okay, and in encryption there are two types. This is the symmetric encryption and asymmetric encryption. Symmetric encryption is actually faster. It is less secure than asymmetric encryption, but asymmetric encryption is a must in a case where I do not know you. For example, me accessing Facebook. Me accessing Facebook is starting by an asymmetric condition, asymmetric encryption. Sorry. Afterwards, after we like build a secure channel, since asymmetric encryption is better, but it takes a lot of CPU usage. It's heavy. It's better, but it's heavy. So I start by asymmetric encryption. I'm gonna like talk about it a little bit throughout this slide. Afterwards, after I like build a secure channel between me and the server or anything else, I then communicate with the server about something that's symmetric. because, as I said, symmetric is faster. It is okay. It is less secure than asymmetric. Both are very secure if used properly, but I start with asymmetric and then I negotiate asymmetric encryption with my server or anything else, and then data will be encrypted using the symmetric encryption. Okay, so asymmetric private. Okay. Let's talk a little bit about asymmetric encryption. Asymmetric encryption, if you guys are familiar with, is certificates mainly. Okay, so asymmetric encryption is me actually trusting a CA. CA is a certificate authority. I'm trusting this authority. Also, I'm gonna give an example of Facebook because this will make it for you guys easy to grasp. Also, Facebook got their certificate signed by the CA. Okay, sorry. I will ask Facebook will just issue, like generate a certificate, ask the CA to sign it, make sure that Facebook is really Facebook in some source. I can tell you about them after the session if you're interested. How can you make sure that you are receiving actually the Facebook certificate, the legit one? So when I open Facebook, if you notice, I do not receive any issues or any like this is not trusted or whatever, because on my computer, there is a list of trusted root certificates. Mainly, most CAs in the world have their signature there. So when I receive the certificate from Facebook, I see the signature trusted by the CA. So I need to trust this. Okay, that's why you do not see like an issue while accessing Facebook. I start my communication using asymmetric encryption. After that, I'm negotiating a symmetric key. Mainly, I'll be using DAS, AES, these kinds of stuff. I'll be negotiating a key so that we can shift the communication from asymmetric to asymmetric to symmetric encryption using these faster protocols. Okay, so that's mainly how things are done. And hashing is actually, it is considered a cryptography thing, but hashing is mainly used for integrity. For example, I'm actually sending you a packet. For those who do not know, of course, I'm sending you a packet. I'm just passing this packet through a Blender machine. This Blender machine is giving me a one-way mathematical value for this packet. I'm just putting this value inside the packet, and I'm sending it throughout the infrastructure, anything. Okay. Once the receiver gets this packet, he's gonna like decrypt the packet, gets this info, and also he will pass this packet through the same machine using the same algorithm that we decided to use. And if both values are the same, this means that nothing changed throughout the process. Nothing changed throughout the medium from the sender to the receiver. This is integrity by itself. We have MD5, SHA, and others. Okay. So there is one thing in this slide that I want to tell you about is Diffie-Hellman. Diffie-Hellman is used in VPN. It's used in actually all types of VPN, if I'm not mistaken, except for SS. So any IPsec communication or any IPsec session, there is Diffie-Hellman. I'm going to tell you now why Diffie-Hellman is like the most important thing in the whole process. Okay, I'm going to talk about Diffie-Hellman in the next slide. Okay, so packet flow, guys, this is very important. This is very, very important in not just like VPN, in anything. If you're troubleshooting, I will answer the questions later because I'm getting distracted. Okay, so this is very important, guys, in anything, not just VPN. You need to know how ASA analyze the packet received. So first of all, I receive the packet. If this is an existing connection means I already started the connection. Let's say it's a TCP connection. It's from inside to outside. The ASA will keep a log that this user is accessing this server. The ASA will keep this log. If the communication is actually replying to this user, this is considered an existing connection. It is not starting a new connection. It is already found, but this is a reply from the server. I will skip all those three. The snort process. So ASA with firepower, there is this Lena. Lena is considered like up to the layer 4. The ASA CLI itself is a Lena. Snort is the source fire. Okay, for now, the source fire is not gonna pass through it because it's not actually directly related to VPN for now. Okay, we're gonna talk about the Lena process. The first thing that's gonna happen, if it's gonna check if this is an existing connection. If not, okay, this will be considered a new connection. The first thing that's going to happen, it's going to pass through the process of a VPN or NAT. What does this mean? This means that actually when I'm receiving, when I'm checking for an access list, for example, the packet is already decrypted. Already decrypted means I do know. Let me just, I need to show you something here. Sorry. I need to show you something here that's very, okay. I downloaded this today. Okay. At this point, guys, natting or unnatting will happen if it is there, and decryption will happen. What does decryption will happen mean? It means that at this point, when I'm here, the packet is actually holding the original source and the original destination. Because as we said, throughout the process, if I actually like get the packet throughout the internet, I'm not gonna see the internal resource. I'm not gonna see the internal source and destination. I'm gonna see the real IP on both sides. Okay, so once this is done, I'm gonna see here, I will be able as a packet to see the real source and the destination. So I will be basing my access list based on this, because my firewall is gonna see the packet, it's gonna see the real source and the real destination. Okay, I know this makes any sense to you guys, but this is very important in the flow of the packet. Okay. Let me just. Okay. Okay, so after that access list, let's forget about this node for now. We're gonna check the headers. We're gonna do quality of service, VPN encryption, decryption. That's going both ways. And then final thing I'm gonna do is routing, or if it's a layer 2, it's layer 2 like IP. I'm gonna just forward it. Okay. Here's the big deal. Okay, I want to build a VPN connection. IPsec VPN connection. Again, it's IKV1. It's not IKV2. The processes are somehow similar. IKV2 is way more flexible with a lot of options. But for now, let's talk about IKV1. Okay, IKV1 has two phases. It's phase 1 and phase 2. The phase 1 is actually me starting the communication. I have two firewalls. Okay, I want to start a VPN connection. For me to be able to start the VPN connection, for security reasons, of course, I need to be debating with the other firewall what are the protocols that we should be working on. Because if both ASAs have they are not compatible with the protocols, or the proposal, it's the technical word, the proposal, it's not gonna work. Okay, so phase 1 is actually me starting the communication. I will be sending my proposal to the destination. I will be sending okay, so phase 1 consists of 5 major things. Exactly, that's Haggle. This is in CCNA. Exactly. Authentication can be done in 2 parts. It's either I use certificates or I use pre-shared keys. If I want to use a certificate, it takes more time to configure, but it's actually much more trusted. It is much more recommended in case you want to do it. If you can do it, it's better. But for the ease of use, we usually use pre-shared keys. So authentication is either certificate or pre-shared keys. Second part is encryption. Remember, guys, this is not the encryption of the data. This is just me building an original tunnel with the destination. Afterwards, after I build a secure tunnel, I will be negotiating with the partner or with the facing firewall what I will be using to encrypt the data. Okay, please, this is very important. Phase 1, I will not be sharing anything related to data. I'm just building or negotiating a tunnel with the peer, so that afterwards, after I build this secure tunnel, I can easily then share my proposal for the encryption of the data. Okay, that's actually phase 2 is IPsec by itself, is the real deal. Okay, so I will be negotiating my encryption. I can use AES, DAS, 3DAS. Of course, AES is recommended. DAS and 3DAS are actually not very secure nowadays. They are cracked somehow. Hashing, there are 2 types with a bit value. It's either SHA or MD5. There's something called HMAC. We're going to talk about it later. And the Diffie-Hellman group, it's either 2 or 5, or if I'm using like IGV2, there are a lot of options with a lot of big like values for Diffie-Hellman. Of course, the bigger it is better. Yes, Emmanuel. The bigger it is better, but this is actually consuming, as I said. So 5 is okay. You can use 5. And the lifetime. Lifetime is actually me telling the firewall that's facing me that I want to build this phase amount of time. Afterwards, I'm gonna like renew the tunnel. I'm gonna then send you this, and everything will happen again. Okay. The most important thing here, guys, this what I'm gonna talk now is like very important. If you search for it, it's very tough to find it in the books. Okay, so let me tell you how everything happens. Diffie-Hellman, guys. Diffie-Hellman is the magic behind everything. What's Diffie-Hellman? Let me jump to this one. Okay, so Diffie-Hellman. I'll be okay, whatever. Okay, so Diffie-Hellman. I'll be like creating, let's say. Let me use this again. Okay. Okay. So first of all, we're gonna start by the pre-shared key. Of course, that pre-shared key after I like build this, share my proposal with the peer. I will be building. I will be generating, sorry, a key. Okay, I'll be generating any key, and I'll be sending. I'll be adding this key. This is how actually the pre-shared key is being authenticated. I will be building a key after I just negotiate with the peer that we will both be using like a group 5 for the Diffie-Hellman. Okay, that's checked. Afterwards, we're gonna have both guys the pre-shared key, right? Pre-shared key is not shared. If it is shared, then there is no point in security. Anyone can get it. But I'm gonna tell you how it's shared. I will be having my pre-shared key that should be similar on the peer, right? Afterwards, I will be generating like a group 5. It's actually size. I will be generating a size for the Diffie-Hellman. This is actually a key. Okay, and the peer will do the same. Of course, they are not gonna be the same keys. Afterwards, I'm gonna like join. I'm gonna like add the pre-shared key to my key, and the peer will do the same. Okay, we're gonna have like a mixture. Let's call it like a C key. C. It's a pre-shared key. B is the generated key. C is the mixture of both. When we share the mixture of both, we can both share. I'll be sharing mine to him to it. Sorry, and the other firewall will be sending his mixture to me. After that, I'm gonna add to this mixture my key that I created, and he's gonna add his key that he's created. If you think about it, we are both having the pre-shared key, my key and his key. He's gonna be having his pre-shared key, my key and his key. The combination of these three things will have an equal key. Okay, so if I know, guys, this is like the first time. I know this is the first time they've heard of it, but this is how Diffie-Hellman works. This is how I authenticate the pre-shared keys, and this is how we both have a similar key throughout a public infrastructure. It is a very smart way to start things. Okay, so afterwards, I am now ready for the phase 1. Phase 1 tunnel is up. Okay, but as I said, phase 1 is just, its only purpose is just to build a secure tunnel so that I can. I will be talking about phase 1. Okay, don't worry. I will be talking about what should match and what. Let me just. Okay. So after Diffie-Hellman makes this magic, I'm gonna have a tunnel. Okay, it's a secure tunnel. Afterwards, I can then like work with. After that, I can work with sharing. I'm gonna jump to phase 2. I'll be working with my peer to like negotiate what actual encryption or encapsulation we're gonna be using to like apply on data. Okay. In phase 1, guys, authentication should be the same, exactly the same. Encryption should be the same. Hashing should be the same. Diffie-Hellman should be the same. If you do not like configure Diffie-Hellman, it's gonna like take group 2 by default. Lifetime, it can work if they are not exactly the same, but it is recommended to like be the same because you're not losing anything. This is actually just if you like the first the ASA with the lower lifetime, he's gonna tear the first tunnel, and he's gonna renegotiate a tunnel. Okay, but that's it. It's not gonna like ruin everything, but the above should like match. Okay. Okay, so phase one can happen in two modes. I'm not gonna like get deep into this. If you wanna know info about this, I can tell you. It has two modes, either aggressive mode or main mode. By default, it uses main mode. Main mode is better, but main mode actually uses 6 packets to do all of this. Aggressive mode actually like combines the proposals and send them in a 3-packet way. Okay, you can see the picture here. Phase two. Okay, so phase one is done. I can now talk to my firewall, to the peer firewall, but in a secure way, of course, as we said. But I haven't negotiated the proposal, or I haven't negotiated what it is called transform set. If you guys, of course, you guys know it. We're gonna be talking about the transform set, which is the encryption. What algorithm will encrypt my data? Okay. In the phase two, actually, we're going to be talking about four components. The IPsec protocol is actually a framework. IPsec is a framework. It's not actually a protocol. It's a bunch of protocols. Mainly, we care about encryption, authentication, and Diffie-Hellman. I'm going to tell you about Diffie-Hellman. Diffie-Hellman is used in phase two. If you ever heard, guys, of something called a PFS. PFS is perfect forward secrecy. It is recommended. It is not mandatory to use it. PFS will actually trigger after a certain time for the secondary tunnel to rekey, to change the key. Why we do that? Actually, let's say the key that we are using is compromised. Okay, let's say we're using it for 24 hours. It's compromised for some reason. PFS is the solution for this. PFS will actually trigger Diffie-Hellman every like 1 hour. You can play with the settings, but this will assure that I'm not like the communication is not being like decrypted by some third party you get my point. Okay. So phase two, actually, I'm discussing with my peer what are we using for encryption and decryption, and we move on. Phase two is symmetric. Okay. Phase one, which is Diffie-Hellman, we are starting by an asymmetric. Okay, asymmetric. As I said, it is better in terms of security, but it takes a lot of CPU and resources. So we start by it. We build a secure channel. Afterwards, we can safely negotiate a symmetric algorithm, which is DAS, 3DAS, these kinds of things. Of course, guys, it is recommended that you use AES. Okay, AES is better. The larger the number, it is better, but you need to be careful about the resources of the firewall. ESP, the thing that you hear about ESP is not the encryption, it's the encapsulation. So if you open Wireshark, you're not going to see DAS, you're going to see ESP. ESP is actually encapsulating the encryption inside the packet. Okay, this is phase one. So the complete story, guys. Here I'm going to tell you from A to Z how everything is happening, and I'm going to tell you what are the things that you need to like be careful working with, or you need to like note while configuring site-to-site VPN. This is the scenario. I like have 2 firewalls. Of course, each one is like in a site. Let's say ASA1 is in site A, ASA2 is in site B. Of course, we have like end users in each site. They need to communicate with each other. Maybe you need to communicate with a server or whatever. Site-to-site is your key. Site-to-site VPN is actually the best scenario that you can do. Okay, site-to-site VPN. I'm gonna start by first of all. Site-to-site VPN is using crypto maps. Okay, on ASAs, you have 2 ways of doing a VPN. There's actually something called site-to-site VPN, which is crypto map actually, and there is a tunnel. Like 5 years ago, sorry, ASA didn't have the capability of tunneling. Okay, but still now ASA can have a tunnel, but it is not a GRE tunnel. Okay, if you want to like have a talk about this, we can talk about this after the session. It's not directly related to the session, but I can do IPsec tunnels on the ASA, but not GRE tunnels. GRE tunnels are actually, which means that I cannot do DNVPN on the ASA, but I can have site-to-site IPsec tunnel. Actually, I'm going to have an interface tunnel, the same as the router, and I'm going to be moving forward with this using IPsec only. Okay, so by default, if I configured a VPN on both ASAs, nothing will happen. Okay, nothing will happen at all. The thing trigger this negotiation, the phase 1 and phase 2 negotiation, is interesting traffic. What do I mean by interesting traffic? I'm a user. Okay, I actually configured the firewall to do encryption only if a user from any user from the subnet 1.0 is actually communicating with the subnet 2. Sorry, it is 10.0.0.0. Okay, when my firewall see or hits this access list or this source destination IP thing, it will trigger the VPN. It will trigger the communication. It will trigger phase 1, phase 2, and everything will work like this. Unlike tunnels, when you configure tunnels, they will directly come up. Okay, so I'm a user. I'm from 192.168 subnet. I want to access a server in the 10 subnet. It's on the other side here. Okay. Once I ping or I do whatever communication, the first packet that actually matches the access list on the firewall, this will trigger my VPN. After this will trigger my VPN, I'm going to negotiate phase 1. Phase 1, okay, my proposal is fine. As I said, lifetime can be different, but it is recommended not to be. Why actually? Why should I, like, you can test it, it will work, but it is recommended to be the same on both. I'm going to jump to phase 2. I'm going to negotiate encryption. Afterwards, I am ready. I can actually start encrypting traffic over the internet and sending it to my peer. Throughout the way, if I'm a hacker on the internet, if I'm able to see the packet, I will not see anything except source, real IP, source and real IP destination, and everything else will be encrypted. Okay. Once the packet is received by the ASA2 by the second site, the first thing that's going to happen, ASA is going to decrypt my packet, and the flow that I told you about, it will be moving in the same flow, and that's how I receive. The server will receive my request, and same thing goes vice versa. Okay, so now let's jump to the live demo. I just want to know if someone has any a quick question or something before I continue, because I saw a lot in chat, but I didn't like. Yeah. Kelvin, you here?
Yep, I'm here. Yeah, great session so far. I think we've had some good conversations going on in the chat, and I'm sure they'll continue into the WebEx Teams group. So well done so far. It's been a good, informative session.
Okay. So I'm gonna jump to the live demo now. Okay, this is a very I'm doing it on my laptop. Okay.
Hello.
Yes.
Yeah, Ramza, sorry. I just want to ask a very brief question.
Yeah.
You know, when you are trying to create a VPN tunnel, let's say an IPsec tunnel.
Sorry, can you just make? I can't listen well. Can you just
okay.
Raise your voice?
Okay, can you hear me properly now?
Okay, it's better.
Okay, so basically what I was asking is, when you're trying to create a VPN, let's say an IPsec VPN tunnel to be precise. You know,
Okay.
if you are creating that VPN on a router, you can actually use probably to do a test. You can actually use a loopback interface. You understand what I mean? Let's say I have a VPN between maybe a router and an ASA firewall, correct? And maybe you're having issues with end-to-end reachability. You understand, right? So probably you are trying to do a troubleshooting session, and you can see that, okay, for the phase one is actually forming, but you are seeing that there's no end-to-end reachability, meaning it's getting stuck on the phase 2.
Charles, I'm very sorry. I'm not getting the point, and your voice is very, very low. Can we just leave this to the end of the session? I'm sure. Okay, I will get back to you after the session ends so that we can make things more clear. Okay, guys. So this is my scenario. Nothing fancy here. I just have two ASAs. First PC in the first site, second PC in the second site. I'm using GNS. I'm using ASA 9.8. Okay. I'm gonna like be moving forward with the configuration. I'm gonna be talking about it. Okay, that's an ASA from scratch. I did nothing on it. Okay, so okay, I'll be doing the configuration. Okay, this is actually the outside interface. Okay, the IP will be 1111. This will actually, it can be like another subnet on the other side. I'm just doing this for simplicity. It will be the same subnet, but the same goes on. Okay, IP address, name if outside, done. Interface gig 01. This is the inside, guys. This will be the gateway to my computers. Okay, for simplicity, I'm gonna do a default route to the secondary firewall. Okay, to make sure that I don't have any issues regarding routing. Okay, route outside 00. Route outside. Okay. Yeah, next stop is match IP address. Oh, okay. So I did something here. Okay. I had the same address. Okay. This is routing sorted. Oh, so guys, this is the access list. This access list, you need to think of it as it's just for matching. It doesn't like restrict anything. It is just if I match this access list, I will be triggering the VPN that I showed you in the earlier pictures. Okay, so access list extended access list. Let's call it VPN extended permit. Here I can choose the interesting traffic. It should be based on source and destination, not only source. Okay, and guys, this is very important. If you have actually like misconfigured access lists on both sides, okay, this will trigger an issue. You will have an issue. Okay, you can actually have larger subnets. This can work, but if you like mismatch on both sides, this will trigger an issue. Okay, VPN will not work if both access lists on both ASAs do not match in a vice versa way. Okay, so I'm going to do an access list to like match the traffic from my site to the other side. Okay. Permit 192.168.1.0. Okay, there's IP here. Okay, guys. So as I said, this is just for matching. Once this is matched, triggered, whatever, this will trigger the VPN access list. Okay. So afterwards, I'm gonna start my proposal. This is my crypto IKv1 policy. Okay, 5. Here, crypto IKv1 policy. Here, I'm stating my phase 1 proposal. Okay, the number 5 is irrelevant. Okay, so it is used. I can have multiple policies and I can have multiple site-to-site VPNs. So by default, when I receive a VPN, the peer wants to negotiate a VPN with me, I'm gonna be starting a phase 1 from the first policy, from the like number 1, 5. It will be moving in this increasing order. Okay, but it is irrelevant. You can choose any number. Okay, it doesn't show anything. Authentication for now, we're gonna use pre-shared key, encryption, AES. We still have group, the VPN group. This is by default too. You can actually you can see it, but for simplicity, I'm gonna type it. Authentication, encryption, crash, lifetime.
Ramzy, sorry to just jump in there, and just a quick one for everybody on the call that might not know. The IKE or the ICMKP. Basically, if you remember, you can remember it by saying to yourself Haggle. So hashing, authentication, group, as in Diffie-Hellman group, lifetime, and encryption. That's what Haggle stands for. If for those on the call that want to wear.
Exactly. Yes. Thank you for that. So if you guys want to remember the phase 1 proposal, it's haggle. As Kelvin said, hashing, authentication, group, the Diffie-Hellman group, lifetime, and encryption. Okay, so I just chose my five elements, or my 5 parameters. Afterwards, I'm gonna be doing like crypto IGV1, crypto. Sorry, this is the transform set, guys. This is where I'm gonna be mentioning my phase 2 proposal. Okay, IPsec IGV2 transform crypto IPsec IGV1. Sorry, set. I'm gonna call it set. Okay, I'm gonna be using ESP AES as an encryption, and for hashing, I'm gonna use ESP HMAC. Okay, this is for phase 2. Strictly for phase 2, nothing else. Okay, so now I'm gonna be configuring my crypto map. Crypto map, as I said, it's either a tunnel or a crypto map. Crypto map is actually will be linked to my interface, and as I see matching traffic, I will trigger a VPN connection. I will trigger a VPN negotiation with the peer. Okay, so crypto map, I'm gonna call it map or whatever you can call it here, VPN. Here you're gonna state a number. Okay, I'm gonna set my peer. I'm actually telling my VPN what's my firewall, what's the IP of what's the real IP of the peer. Okay, so in my case it's gonna be 1112, the facing IP, crypto map VPN 10 set transforms set IPv1 transform set. Here I'm gonna stating my transform set, my phase 2. Okay, crypto map VPN. Here I'm gonna be asking my firewall VPN 10 match address VPN. Here I'm telling my firewall that I want you to be looking throughout my traffic. If you get a match on the source and destination, you can then go and trigger a VPN connection, or trigger, as we said, a VPN negotiation with the peer. Okay, VPN is actually the name of the access list. Okay, and finally, set peer set match. Finally, let me just crypto map VPN 10. Let me just remember. Okay, set. Okay, guys, do you see the PFS that I told you about? PFS can be used here. It's not mandatory. You can use it in case you wanna like kick up a notch your security. It's, as we said, it will be triggering rekeying every certain period of time. Okay, so okay, so here I'm gonna be, okay, that's very important. That's me actually telling the firewall I'm using this to tell my firewall what is the pre-shared key. And it is very important here. Okay, so tunnel group, if you do question mark here, it's gonna tell you to put a word. If you put a word, it's not gonna work. Okay, if you guys are using pre-shared keys, if you are using pre-shared keys, here we use the IP of the peer. Okay, tunnel group, use the IP of peer. Tunnel group, remember, type IPsec L2L. L2L means LAN to LAN, LAN to LAN, as in site to site. Okay, and tunnel group. If you are authenticating using certificates, you can use a word here. But if you are using site to site using authentication as a pre-shared key, it is mandatory that you use the IP, else it will not work. Okay, this is something that I have noticed throughout throughout working with this. IPsec type IPsec attributes. Let me just recap. Okay. IPsec. I don't know what it's not showing. IPsec. I think something with there. It's happening.
I think you made a mistake in the IP. You said you did 1.1.1.2. at first.
Yeah, exactly. Yes. Okay, so here I'm gonna do it. Okay. Okay. So, as Calvin said, I was using the wrong IP, so it didn't like match to it. 1.1.1.2 IPsec. What? 2 IPsec attributes. Here I'm gonna be using I'm gonna be stating my pre-shared key in this form. Pre-shared key is called Cisco 123. Okay. Let me check my configuration. So I have inside, outside. Everything's okay. I have this access list to match. I have the route outside to make sure routing. We don't have any issues with issues with routing. I lost my okay. My transform set is actually ESP AES, ESP SHA HMAC. My policy is pre-shared key AES SHA. I'm using group 2 and lifetime is the default. And okay, I think that's pretty much it from this side. I'm going to be jumping this side and I'm going to be doing the configuration very fast. You can do it in your head with me. Okay, so interface gig 00, IP address 1.1.1. MF outside, no shut, exit, interface gig 01, IP address. This is going to be the gateway to the second site. Routing. Routing is done. Access list extended. Access list VPN extended. This is the access list that I told you it should match on both sides in a vice versa manner. Okay, so I did 1 to 2. Here I'm going to do 2 to 1. Okay. Okay, I'm gonna start with policy crypto IG1 policy. I'm gonna say like 23 to show you that it doesn't matter. Authentication is pre-shared. Hashing is SHA. Diffie-Hellman is 2. Lifetime is 86400. And encryption is AES. Done with this one. I'm gonna start with my crypto maps right now. Crypto map. I can also call it any name. I'll just call it for simplicity also VPN. This is the process ID. You can have multiple crypto maps. Set peer 1.1.1.1 crypto set IGV1 I forgot the transform set. I'm gonna do it now. Transform set. Okay, I'm gonna do it now. Crypto IPsec IGV1 transform set AES. This should also, as I said, this should match ESP AES ESP SHA HMAC. Now I can use this one. Crypto okay, crypto map VPN 10 set IK1 transform set. I called it set. It's just a name. Okay. Okay. Now it's time to match VPN match VPN 10 match address. This is the access list. I called it VPN. So let me just check. There should be 4 crypto map commands. Okay, crypto map match set. There's still one more set. Set IXV2 set peer match and which is the first one? Match address. Okay, set peer IXV1 transform set. There's something that I forgot. I will do it now. Okay, guys. In order for this to work, you need to enable first of all IXV1. That's the thing that I didn't do. Okay, I will do it on both sides. I will be enabling crypto IXV1 enable outside. That's if you do not do that, it will not work. Okay, I'm enabling crypto v1 outside. This will like be listening and will be triggered if anything happens. Okay, I'll be doing on both sides. And the other thing that I forgot is CryptoMap VPN 10. So it's not 10, CryptoMap VPN. It is lagging. I need to go. Okay. Okay. CryptoMap VPN. Enable interface, sorry, outside. Okay, here you're telling the crypto map to be triggered on the outside interface, not the inside. This is the interface that's gonna have the real IP usually. Okay, so I need to do it on the first one. I forgot about, there are two commands that I forgot about. Crypto v1 enable outside, and crypto map VPN 10 interface, VPN interface outside. Okay. So I think we are ready here. Everything's okay. So as I said, in order for this to work, we should be triggering traffic. The firewall should be triggered by an access list in order to do the negotiation. Okay, I'm gonna just show you that for now, nothing is gonna happen. Show crypto v1 Okay, this I'm gonna talk about this a bit later, but now nothing is happening. Okay, I'll be accessing my first computer, the one that's considered to be at the first site. I'm going to give it an IP 1.2. Okay, the second one. Okay, so now for now everything is set. Is not reachable. Let me just check why. Oh, I'm doing a ping.
It should be IP.
Yeah, I'm doing a ping, sorry. Okay. Okay, so I'll be pinging the first. This is me pinging the computer in the second sign pinging the first computer. Okay, let's see if it's gonna work. Okay, great. This should work, but we're gonna troubleshoot it together. Okay, so what I'm gonna do, I'm gonna be jumping because I lost track of time. I'll be jumping to the troubleshooting part. This is me actually troubleshooting what's happening because I really don't know what's the issue because I was configuring it with you guys. So let's check. What I'm gonna be doing is this. I'm gonna be debugging. First of all, what I care about is me debugging the first phase. There is no NAT here, man. There's no NAT here. I'm gonna talk about NAT and what should you do if you have a device that's actually doing NAT. For this case, there is no NAT. Okay, so what I care about are two things. Okay, two things: phase one and phase two. Okay, if phase one is okay, I can then jump to troubleshooting phase two. Is phase two okay? Then there is something else that's going on. Okay, so first of all, this happens 70% of the time where I debug phase one issues and I find that something is not compatible. Okay, so debug crypto v1 SA debug crypto v1. Oh, okay, so it's debug crypto v1, no SAS. Okay, and I'm gonna do a ping here to see what's going on. This is okay. So it's telling me that can't find a valid tunnel, aborting. Okay, can't find a valid tunnel. what I do usually, I'll be jumping to my guide. I actually have a guide.
Is it suggesting a tunnel group is missing?
Yup. There is no tunnel. Exactly, man. So it's saying that tunnel like had invalid missing as payload. So that this means actually I forgot to like configure the tunnel group, which is exactly what someone here mentioned. Tunnel group. It should be the IP of the peer. IP type, IPsec LAN to LAN. Same thing here, but IPsec attributes IKv1 pre-shared key Cisco 123. Okay. I'm not gonna do anything now. I'm just gonna issue this command show crypto Isaac. Sorry, it's IKv1. There are two commands which actually can help you 90% of the times. The first one is show crypto IV1 security associations, which is SA. There's actually none because phase 1 did not come up at all. And there's show crypto IPsec SA. Okay, that's like the 90% of the time. There's actually you can do debugs. It's very good. Okay, so I'm gonna do the rest now. I think the first one is actually. This is a good indication, okay? Because guys, if you did the configuration and it didn't work, this means that is a VPN issue. If it did work, it means your VPN is 100% right. How can I make sure that my VPN is actually right? This is someone just wrote it in the commands in the section in the notification section. Show crypto IPsec SA. This IPsec SA, as we talked about, is phase 2, is the actual data encryption. Okay. When I see packets encrypted 4, packets encrypted 4, packets encrypted 4, this is the perfect sign that everything is working fine. Okay. This is actually site-to-site VPN, guys, with all its parameters. I did my best like to share everything I know. Since we don't have a lot of time, I will be just mentioning the troubleshooting that I think is very important. So these 3 things, it's actually 90% of the time, it's these 3 things. Okay, it's either here are the debugging messages. It's either if phase 1 doesn't match, you're gonna see in the debugging this message: information exchange process failed. This will tell you that there's something wrong with phase 1. Okay, then you need to check phase 1, the policies on both sides. Okay, if you get an IP such as error, no crypto map matched, I think this is the issue that we had earlier, because we actually I didn't do the sorry, this is not the issue that happened. If you see no crypto maps match, this is showing that you're actually doing crypto maps but they do not match. Okay, and final one, if you're doing like if the ACL isn't the same, I told you about this, or if the IPsec proposal, the transform set is not the same, you're gonna see your firewall like removing peer session is being torn down. You're gonna see this message, these 2 messages all the way. Okay, I also have like some information, some like useful links that I can share with you guys for troubleshooting. They are I actually use them most of the time, and they solve 95% of my issues. There's a thing that I want to tell you about in case, guys. This is the final thing after I give it to Kelvin. Let me use my pen. I downloaded the pen today. I'm very happy to use it. Okay, so this is the pen. Actually, guys, sometimes you're going to be facing a scenario where there is a router here, and the real IP is not on the firewall. It's on the router. Okay. In this case, it is very simple. You can do everything as it is, but you need to be doing static NAT on the router. That's it. You're gonna need to be forwarding only. If you want to be very specific, Isakmp works using UDP 500, and ESP, which is the data encryption, will be using either 4500 if you're using NAT. In your case, this will automatically be detected, or 50 in case there is no NAT. Okay, so what you have to do is only configure static NAT on the router, Okay, and you will do the configuration exactly the same. Of course, on this firewall, you're going to be mentioning this real IP. You're not going to be mentioning the inside IP, of course, and everything is the same. So this is pretty much it. I hope you guys found some of my info informative for you. You learned something, because at the end, that's what it's all about. Kelvin, you here?
Yep, I'm here. Brilliant. Thank you, Ramzy, and thank you for offering to give your demonstration and your time to the group. I think that were a great session, and I think you covered quite a lot. So yeah, hopefully people have taken away some useful information from that. Okay, so in the interest of time, we'll jump straight into the firepower bit. Ramzy's done a great job in explaining the technical parts in terms of the IKE v1, IKE v2, IPsec, etc. So we should be able to save some time on that. I'll just go ahead and share my screen.
One final thing, sorry, guys, if you're doing site-to-site VPN, usually there's NATing, of course. You need to be careful to use NAT-Examp. NAT-Examp is very important. I didn't cover that because in my case, I didn't have any NAT so far. So to talk about it, so NAT-Examp is very important, so that when the source or destination are being matched, to not be natted by the interface. Okay, so you need to do NAT-Examp only in terms of source and destination to be at the sites. Okay, so that's very important if you want to do the configuration in real environments where most of the time you have NAT. Okay, so that's it.
Brilliant, thank you, Ramzy. And yeah, just on that note, in fact, there's a lot of different features and different things you can configure when you're configuring site-to-site VPNs. So we haven't got enough time in the 1 hour and a half that we've got to actually go through everything in detail. But the point of it is just to show you how to we can configure these things, and then we can go away and do some further research and spin up our own labs and configure them as well. And then if we've got any questions, we can post them in the group, because that's what it's for. So I'll jump straight in with the interest of time. I know we've got about 20 minutes left or so. So this part, we're going to look at the firepower site-to-site VPNs. What I've done is I've kept it short and sweet, or tried to keep it short and sweet, pretty much similar to how I deliver my other presentations on my channel. So we'll start by going over the site-to-site main points for firepower. So from the top, the firepower site-to-site VPNs, they support IPsec, Internet Key Exchange, so IKE v1 and IKE v2. In terms of pre-shared key, we saw earlier Ramzy configure a pre-shared key. With the firepower devices, we have the ability to actually configure either a manual pre-shared key, as Ramzy did, or we can also configure an automatic pre-shared key. So this is whereby you don't actually specify any parameters there. You just select automatic pre-shared key, and firepower will do its business there. Same with the ASA, we can also configure site-to-site VPNs using certificate authentication. That's not going to be covered in today's demonstration. We'll be doing similar to what Ramzy's done, but for the firepower. The site-to-site VPNs, IPv4 and IPv6. We've got tunnel statistics, which are available via the CLI. So by that, you can issue commands on the CLI of the FTD appliances to verify that your configuration is indeed correct and working. You also have the ability to configure 3 different types of topologies. So we've got the point-to-point or the LAN-to-LAN, which is what Ramzy just configured and what we'll be configuring today as well for the firepower. However, if you want to configure different types, so hub and spoke is supported, and also full mesh, depending on your environment. FTD VPNs are not supported in clustered environments. So if you've got FTD clusters, then VPNs are not supported. We've got a couple of supported IKE and IPsec proposals here. So for the encryption, which we spoke about. We're not going to go into detail in any of these, but I've included this just so for information, and if you want to go away and research it a little bit more, then feel free to do so. But pretty much standard, same as the ASA. So we've got the AES, and we can specify 3 different lengths. So we've got the 128, 192, and 256 bit. And then for the integrity or the hashing, we've got the SHA. So we can either use SHA 160 all the way up to 512. And then for the Diffie-Hellman key exchange, we have modular exponentials. So these are, I think, what Ramzy configured. I can't remember what you configured, in fact, to your Diffie-Hellman group, but we can go up to, all the way up to group 14. And I don't know if you can go beyond that, actually, but these are some of the Diffie-Hellman groups that we can actually configure. In order to configure any VPNs, we need to make sure on the firepower we have under the license section, we need to make sure that export control features is enabled, or we won't be able to configure any sort of VPN. Pretty straightforward with the firepowers in terms of configuring site-to-site VPNs. As well, for those that know already, we know that we either configure our firepower devices either using the firepower device manager, which is the on-box management, or we can configure our FTDs using the firepower management centers, or the FMC. We don't use the CLI. For those that don't know or less familiar with the firepower appliances, everything is done pretty much on the managers. So in terms of configuring, we've got 7 steps here. So we create a new VPN topology. We then select the IKE version. We select the endpoints for the site-to-site VPN. So this is the interesting traffic that Ramzy was referring to earlier, the traffic that we want to be encrypted across that tunnel. We configure the IKE settings, then we configure the IPsec settings, and then we deploy the policy, and then we can test and verify the site-to-site VPNs. And we'll take a look at all of these within the time that we've got. Fortunately enough, we can get it done within that time. So in regards to the demonstration today, this is the topology that we're going to be looking at. So on the, just get the little annotation and open if it works. Go. So we've got the VPC3 down here, and we've got VPC4, both on 2 separate networks separated by the 2 firewalls. We're going to have the VPN, the site-to-site VPN, from Firepower 1 and Firepower 2 here. So the tunnel interfaces are going to be these 2 interfaces here. And then the interesting traffic is going to be from within these 2 subnets, so 192.168.16.0 and 15.0. And I've also included a separate environment here, and this is just so that we can see that when we communicate with these, let's say for instance from here all the way to the VPC3 down here, we can see that the tunnel is not established because that's not part of any interesting traffic. All the rest up here, this is just connected to a firepower management center, so don't worry about that. Okay. So what we'll do now is we'll jump into the demonstration, and then after that we've got some verification commands we can quickly run just to verify that we've got our connectivity up as required. So this is the topology. We'll jump straight away to the FMC. So the underlying network infrastructure is configured in terms of IP addresses, etc. So we don't need to worry about that. Let me just move that across here so I can see that. So to configure the VPN using the FMC, then what we need to do is we go to devices, and then we go to VPN, and then we go to site-to-site. Got just over 10 minutes, so I should be able to get all this in. So when we get to site-to-site, we need to either add VPN, or I just simply click here, Firepower Threat Defense Device. and then we give our topology a name. So we'll call this one, not daemon, we'll call it demo. And today, as I say, we've got 3 different types: full mesh, hub and spoke, and point-to-point. So we'll configure point-to-point, and we'll leave the default selected IKV2. So node A and node B, so these are essentially the VPN termination points. So if we click on the little plus icon, we can select the device. So in my case, the first one is FTD004, and we'll call the interface is S2S or site-to-site. And you can see it's populated the outside interface IP address again here. We'll leave the connection type as bidirectional. So what this means is if is this interface either going to only listen for a tunnel establishment, or is it bidirectional? Can this interface process those as well? Certificate maps are related to certificates, so we're not going to touch that. And then the protected network. So this is going to be the interesting traffic that we want to include. So if we go back to our topology here, we want to include the 15.0 subnet. So to do that, we just click on that, and then that's already populated as an object. If it's not, you can create your object here, and then we'll just press add and OK. And that's the only network that we're concerned about for that. And then for node B, so our other side, we then select our other FTD device. So this is FTD5. So this is this device here. Again, we select the interface. So it's S2S FTD here. We can see again that the IP address has been selected. And we can leave this as bidirectional as well. You can see there we can either originated only, so traffic originated from this interface, or we can answer to site-to-site traffic if we wanted to, but we'll leave that as bidirectional because this means that any side or any initiating interesting traffic can cause the establishment of the tunnel. So again, we need to add the IP address into the interesting traffic, the subnet. So 16.0 is our subnet for this side. So we'll add that in there. So 16.0, it's already created. Okay with that. Okay again. And then once we've done that on endpoints, we then go across to IKE. So we're using IKV2. So you can see that we've got a pre-shared key automatic, which is default set, or we can specify manual or certificate. So we'll leave it as automatic, and we can actually specify the key length. So we'll leave again that at default for the interest of time. Policies, we can use policies that are already configured, or we can create policies like I have here. So I've called one demo IKE. So to create your own policy, you click the plus icon, give it a name, specify your lifetime. So this is pretty much the haggle phase in which Ramzy went through on the ASA. So we specify the lifetime, etc. You've got a list of algorithms that you can use, encryption algorithms, and then Diffie-Hellman, etc. If you use something like Galactic Curve, AES, then we don't need to specify Diffie-Hellman. I think it is. It's not going to be SHA, but anyway, it'll prompt you before you save it. It won't allow you to save it if the selection that you specified is not valid. So for our case, we'll just quickly use the one that I created previously, and then we'll go across to IPsec. So this is a phase 2. So we'll leave the crypto map as static, tunnel, IKV2 tunnel, and we'll pretty much leave all these settings as they are actually because of the time. I won't touch on all of these settings. I will share a link actually if you're interested in knowing a bit more about these, because there is an advanced section as well. But the default ones, especially for labbing, you should be okay with. But it's also worth, obviously, for the exam, which is why we're doing this, to make sure that we understand all the different options we have available to us. So enable reverse route injection. This is basically going to include the route statically into the routing table. So we'll take a look at that after. We should be able to see that. And then, we've got some advanced settings here that we can configure as well. So we'll leave those alone for now. So once we've done that, we'll just go ahead and press save now that we're happy with that. And then you can see there that we've got our first site-to-site VPN configuration. So now that we've done that, we'll just go ahead and deploy that. And what we want to do is deploy that to both of the devices. Obviously, if you're in an environment whereby you only have one managed appliance, Cisco appliance, then you'll only apply this to one device, but you need to obviously make sure that the correct configuration is on the secondary node. So we'll just deploy that now, and while we deploy that, I will configure the PCs, or the VPCs rather. So I'll just quickly start those. And if we, on the actual FTDs, if we just do show crypto Isakmp SA, so we can see as same as the ASA, we can see that we've got no security associations at the moment, and we can do the same with IPsec. There we go. And we can see that we've got no security associations there. So 899. So if I give this an IP address of 92.168.15.10/24 on a gateway of 15.1, it should be, and then we can try and ping that. .1. Okay, so that's cool. So we've got connectivity there. So VPC4. Again, let's get that one up. IP 192.168.16.10 will give this one. 192.168.16.1. And again, we'll just verify the connectivity. 16.1. Okay, cool. That's fine. And then the last device is 32.902. And this one was 192.168.20.10. 20.1. Pin the gateway. Okay, so we've got connectivity there. So right now, if we go back to technology and we want to ping VPC3 to VPC4, let's check the status of our deployment. So they've been deployed now. We should start to see an IPsec and IPsec tunnel formed. So if we do ping 192.168.16.10, the first one should time out while it establishes, and then we see it's successful, and that's the same behavior on the ASA as well. So now if we check out the FTD, so we just up arrow to have a look at the config again, we can see now that we have an security association, and if we check our IPsec, we can also see that we've got the same here as well. You should be able to see IPsec on the other side as well. So we can see that the tunnel is established now. So now if I do clear IPsec SA, this will get rid of the security association. And then if we do show IP, so we can see that there's no IPsec SA So it's took it all down there. So now what we need to do, so if we now ping from the 20.10 PC, which is on here to here, it's going across that interface, but we should see that it's not going to be part of the interesting traffic. So there should be no IPsec tunnel formed. We'll just do that quickly. 192.168.15.10. Or the connectivity might 15.10. So the connectivity might not actually be in place there. Can ping the. Okay, that's fine. We could check that the route is in there. In fact, we haven't got enough time to do that. But let's go back to the actual main focus of the lab. So if we now ping from VPC4 to VPC3, we should now see that the initiations changed. So ping 192.168 15.10. Okay, so that's working. So again, if we check out the, we should have a new security association. So we can see that the role on the FTD4, which is this one here, is now the responder. So if we check out the role on FTD5, which is where the interesting traffic came from, crypto SA, we can see there that the role is different. So the role's initiator. So that's an important point to highlight when you're especially troubleshooting VPNs as well. And you get some more cool information here, such as lifetime, etc. In the interest of time, I know we're going to go over just a little bit, but that's basically how you configure site-to-site VPNs on the firepower devices really quick. We can also issue some verification commands, and I will share this slide afterwards as well if we don't get to cover them all. But we can issue, packet tracer commands, packet tracer input, site to site. In fact, 004 inside. So that's the inside interface. Isakmp. It's just running a little bit slow. Security group. So 192.168.15.10. And then it's going to be 80 Isakmp. And then we're going to 192.168.16.10. And we can issue detailed at the end of that. So let's see what the output is here. So we can see there that the output interface is the S2S interface. Our input interface is the one that we specified, and we should see that it hits a VPN, flow creation, IP options, no on that. There we can see there in phase 10, we've got type VPN, and we can see that it's allowed. So that's another good command to use for troubleshooting as well. Some other quick commands we could use. I'll just quickly copy these in the interest of time. So you can check out the stats for the IKE as well. So this is particularly good if you're looking at the number of packets in and out, especially for show IPsec crypto IPsec stats. So one good thing about when you're troubleshooting IPsec, you can the incaps and decaps is normally an indication as to whether the tunnel is not necessarily established correctly, but whether packets are being encrypted and decrypted. So that's another good command to issue as well. So you've got the destroyed essays. So when we destroyed the essays before, so you can get all that information there as well. I think in the interest of time, I know we're 2 minutes over, so what I'll do is I will leave it there. That's pretty much a quick overview of how to configure site-to-site VPNs using the firepower FMC to FTDs. As you can see, it's a lot quicker doing it via the GUI rather than typing it out, typing all the commands out, and you're less likely to encounter all the mistakes as well. So with that, I hope that this has been an interesting, informative session for everybody. I can see some questions that I may have missed and not answered. So if you want to paste those questions into the WebEx Teams group, I'll do my best to answer them if they're directed to me, or the group can answer them as well. So with that, I will stop the recording.